notifications. I know that's big on Messenger.
Yes, I think it'd be nice.
So for now, I'll do these 5. There might be another important one you're thinking about, but I'll go with these for now and come back if there's any other function I'm missing.
Yeah, I would just say let's think about the scope of it. You know.
Yeah. And when you say scope, do you mean how many people? So
I mean that's very important when it comes to our kind of our planning.
Say usage.
So let's say about 10,000 users in a chat room is something we would like to support.
User size, so up to 10,000 users in a chat room. That's a big chat room. Let me see. So 10,000 users in a chat room. I guess we can make some estimations. How many chats per average user? How many messages? Is 10 a good number? 10 messages
you mean
per day?
Chat rooms per day?
Yeah. How many messages per user per day?
I don't know. I think it's fair for you to just give, example, whatever you think.
Okay, so let's say average traffic. I'll say we're going to want to support up to 10,000 chat room. Let's say averages.
Well, that's the maximum, right?
Yeah. What about
most chat rooms will probably not be in the long tail, but
how does about 100,000 users per day an average sound? I know for Facebook Messenger is way more than that. I think Facebook has 2 billion
users. We're thinking in terms of right now, right?
Okay.
We're not making a billion people.
Yeah. I guess I don't know how often people message on 100,000 per day. 1 million? How many people message per day?
Just say we have maybe 10,000 concurrent users potentially. And
users, I would say about 10 messages per day per user.
Yeah, that might be a good average, but there will definitely be,
average. Yeah.
Some users that are power users and might have thousands of messages per day. Who knows? So the average is less useful there than supporting the power users. Like the Amazon thing where they care about 99 percentile because those shopping carts are the biggest and they make the most money off them.
All right, so I guess these are the base expectations I'm going in with. So chat room size 10,000, average traffic about 10,000 users, consider power users thousands. Yeah, that sounds fairly standard. Now I guess we have to talk about storage size. So we can say storage size. So if we're gonna extend this down. So we have 10,000 users and power users 1,000. So let's say in worst case scenario for the power users, that's 1,000 times 10,000. That's what 10 to the 6 is about kilo gig. So I'd say about 100 gigabits. Let me see if that makes sense.
Well, how big are the messages?
Yeah, that's what I'm thinking. I should estimate.
So let's cap messages at
because it's just text.
A kilobyte. It's just because we're just gonna do text. So at most, let's say people can send a kilobyte worth of messages.
Okay.
Worth of a message.
Yeah. And then per average message, which would be, and then you have 10,000 times that. So it's 10 to the 4 times 10 to the 3. So let's say 1 kilobit times 10,000. Size per day. 10,000.
Well, we have 10,000 concurrent users sending at most 10,000 messages. But exactly.
At most, So number of users,
1,000 messages.
Yeah, that should be good. That looks pretty good. So I can come back to more submissions. I guess I want to, at this point, since we're quite in, I can start doing some high-level mock-in for what components I'd want.
Yeah.
All right, so let me do a box. I'm going to have a typical client. Like we mentioned, that could be a mobile phone, web, whatever we want. From there, we're gonna have. So I'm gonna start off like you said it start something small and then scale up to time. So this will just be some regular chat server. So from there, the chat server should talk. Okay, there we go. So the chat server should then talk to some data storage, which is where we're going to store all of that. Data store. I have to move this over. Yeah. All right. So we have some. Where do I draw an arrow? Oh, there we go. So the client talks to chat server, and then is there a way to do bi-directional arrows? I guess I'll come back to that.
That's okay.
Yeah, I'll just do it twice.
Oh, I got it.
Yeah, you got it. All right, so client, chat server, data store, pretty standard. And
even though like the data store probably doesn't talk back to the server, right?
Yeah,
it's just a response.
And since we're going to be supporting multiple clients, let me sort of do this little. Imagine we have multiple clients messaging, and I copy paste. Okay, great. And then I'm going to have another arrow because we're going to have different chat rooms, different groups. And then how do I do a dot? Okay, this can work then. So I'll just do, so this sort of implies that there's like, etc. There's like multiple of these.
Sure.
Different clusters.
We can also just frame it in terms of like one client with multiple phones.
Okay. Yeah.
Like, because I think it'll be interesting to see like what I'd said, like how do you know which device they're on?
Yeah.
So let's just frame it in terms of one person using it.
Okay. So let's say person A sends message, and then we're gonna want another arrow back to show the chat server responded with all the person's message.
So what kind of protocol does this happen over?
So we'll say HTTP.
Okay.
So person A receives message, and we'll put in here HTTP.
So how does person A receive the messages? Is the client polling? Is it long polling?
Yeah, how do I want to do it? Actually, I guess I could do a WebSocket.
Okay.
For that, yeah.
Why would you choose that?
Because at least in the past, for like side projects that I've done in Django, I know I've always used WebSockets. They're very good for asynchronous messaging.
Okay.
And yeah, so I think this covers like just a basic chat application. Client sends message to server, chat server receives message back. We're storing everything for data persistence. The case. I know I'm gonna want, as it grows, I'm gonna need multiple chat servers.
Yeah, that's fine. You don't have to show that. I believe you that you have like an auto scaling.
Yeah, and then before that, I'd also have like a load balancer in front, so I can distribute a load balancer. And this is just for supporting application as it scales more and more.
Yeah. So yeah, let's assume that's there. You don't have to put the box down. I'm assuming you know that.
Yeah.
So let's dig into the data store and the layout a little bit. Like, well, so how would you design that?
Yeah, what kind of database do I want to use? Either SQL or NoSQL. So we're storing chat messages. They're fairly free flow, and they're sort of like documents. So I imagine NoSQL would be good here because it's not exactly structured data. It's like very free flow. And I know right now we're doing only text, but going forward, if we wanted to then support pictures and video, then it's nice to have a flexible data format. So I'd say NoSQL for now. And I know since we mentioned Facebook Messenger, I know Facebook uses Cassandra, and that's a really good data store for this. So let me put that in there for now.
What makes Cassandra good for that use case?
Yeah, so I remember the specifics about Cassandra because I've not used it myself. I know it's fairly good for as a NoSQL database, but compared to
How
other ones,
how does it differ, for example, from a SQL
like
database?
Mongo or all of the So I know as a document-based data store, particularly when you think of like the CAP theorem. So I know Cassandra is really good for availability and I think it's partition tolerance. Yeah, that's the A and P in the CAP theorem. And since we talked about above that one of the non-functional requirements we want is high availability, having to support AP is really important. And I know Cassandra does a really good job of having high availability and partition tolerance. So that's a reason why we'd want to use that for this, because with the
but compared to what? Like compared to Postgres?
Yeah,
does the Postgres not have those guarantees?
So it does, but Postgres, the challenge here of using a SQL database instead is that it's more regimented with using structured data for a chat application, given that this is more flexible for what our needs are. And particularly as we scale, a NoSQL database I know can handle scale a lot better at times. But yeah,
which like the read or the write? For
the writes, particularly for documents, yeah. Because since it's a chat application, it's probably going to have a fairly close read to write ratio compared to a lot of other applications where the read ratio is like 3 orders of magnitude greater than the write ratio. The application, we send one message and the reads are however many people are connected, but each person is writing back. So it sounds like maybe a 10-to-1 would be fair for this application for the read write ratio.
Yeah, let's talk a little bit about like what would our data models look like?
Yeah.
When you're sending a message, what kind of information?
For sure.
Then how do we model the chat rooms?
Yeah. So
the group messages.
Yeah, so we'll have chat room, say chat message, say chat user. So let me start with chat room. So each chat room would have some ID and it will just be some integer. We don't want it to be null, so not null. Similarly, we want a name for the chat room. This varchar 55. Now, so people know what room they're in. And then we're going to want the users in each chat room. And that will just be some foreign key to the chat user table. So each room would need some ID, have a name, and it have users. Those are the main things. I'm sure there's something else. For a chat message an ID, and each message has the content. And for now, we said it's just text. So I name this text, and that can be empty. That's fine. Else, and the use sort of some source and destination. So source, or let's say, how would you phrase? Source isn't the best term here. I'll say.
Let's say like every message has an owner, right?
Yeah, owner. That's a good term. So yeah, owner, and that'll be some, again, foreign key into chat. Okay. And the destination would